Good morning. In the previous class, we discussed Q notation. Okay, the coefficients and some signals to be represented in Q notation format. Okay, Q15 and Q7 and different numbers Q2, Q3, Q1, any value that after Q, if any number, okay, which represents the number of fractional bits. Just remember that number of fractional bits behind that decimal point. Okay, whatever the value will get, number bits will get, those will called as whole. It is called as whole part with, see here, this is sign bit. Okay, if it is 0 means it's plus sign. Okay, and this is Q15 means here total 15 numbers, okay, are considered as fractional bits. Okay, please go through this. Okay, better you can go through this problem. After the decimal points, 0 multiplied with 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, okay, with addition sign. 0 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 0 into 2 raised to minus 3 plus, and so on, like that. Okay, and behind the decimal points, 0 into 2 raised to 0, from 0 you can start it, plus 0 into 2 raised to 1 plus 0 into 2 raised to 2, 2 raised to 3, 2 raised to 4, and so on. Okay, like that you can solve the problem. Please go through this. Okay, it's very important. And please remember this Q notation format. Okay, and also we will discuss. Wait a minute. In next module, we are discussing about the implementation of FFT algorithms. Okay, in this same module, next chapter, implementation of FFT algorithms, and this program is also very important. Please practice it. Okay, please go through the logic. How he written this program. Okay, this is the DFT equation. This one is IDFT equation. Okay, the exponential term we call it as e raised to j 2 pi divided by n is called as total factor. In terms of total factor, it becomes the equation 4. Okay, then you consider the 2-point DFT computation. Okay, we consider the x of k, substitute k equal to 0, and expand the summation when n equal to 0 and 1. Okay, then we will get like this. Okay, then x of 1 equal to x of 0 w2 raised to 0 plus x of 1 w2 raised to 1. Okay, see here we know that w2 raised to 1 is minus 1. That's why x of 0 is equal to x of 0 plus x of 1. X of 1 equal to x of 0. This is first input sequence minus x of 1. Okay, otherwise you can write plus sign as it is. Okay, this becomes 1. W2 raised to 0 becomes 1, right? X of 0 plus W2 raised to 1 x of 1. Here at this side in the butterfly structure, here we can extend and write here W2 raised to 1. Okay, sorry, W2 raised to 0. W2 raised to 0. X of 0 is equal to x of 0 plus W2 raised to x of 1. Okay, then x of 1 is equal to x of 0 minus of W2 raised to 0 x of 1. Otherwise you can write as it is only. Okay, like this. X of 0 is equal to x of 0 plus x of 1. X of 1 is equal to x of 0 minus x of 1. Okay, this is for 2-point sequence, 2-point DFT. If it is 4-point DFT computation, okay, here we have 4 inputs. Okay, computation of a 4-point DFT can be shown to yield the structure shown in figure 1b. Here we require a total of 4 butterflies in 2 stages of computation. How many butterflies required? 4 butterflies. If it is 4-point DFT means 4 butterflies. Okay, those 4 butterflies can be arranged in 2 stages. In first stage 2, in second stage 2. 2 to the power of 2. Okay, what is the power value? It's 2, right? Then 2 stages. Okay, 2-point DFT means 2 raised to 1, that is equal to 1. That means only 1 stage. Okay, and 1 butterfly. Here, n number of butterflies. That means if it is 4 means 4 number of butterflies. The first stage has 2 butterflies, one operating on x of 0 and x of 2, and the second operating on x of 1 and x of 3. In the second stage, the first butterfly operates on upper outputs of the first stage butterflies, and the second one operates on the lower outputs of the first stage butterflies. Later we'll discuss. Okay. Also, the lower output of the second butterfly of the first stage needs to be multiplied with the total factor W4 is to 1. After you can consider this equation. Okay. Here we can substitute. Here we can substitute k equal to 0, k equal to 1, k equal to 2, k equal to 3. Okay. Then we will get like this. The 4-point DFT. This is the structure of 4-point DFT. See here, but this is first butterfly, butterfly 1, okay, and butterfly 2, butterfly 3, butterfly 4. I think you already studied. You are familiar with butterfly structure. 4-point DFT, 8-point DFT. Yes? Have you studied or not? Hello?
Yes, sir.
Yeah. Okay. Here, how many stages? This is stage 1. This whole part is stage 1, and this part is stage 2. Okay. See here, how we can construct the butterfly? First here, inputs are arranged in bit reverse order. Okay, inputs are arranged in bit reverse order. After x of 0 you can consider, next x of 2, x of 1, x of 3. The first butterfly constructed using x of 0 and x of 2. Second butterfly will be constructed using x of 1 and x of 2. Okay. Then here we construct the third butterfly using the first output of the, this is first output here, you can consider. I'll write here some values here. I'll write here, this is for 1, this is 2, 3, and 4. Okay. See here, if 2 inputs, here you consider this butterfly, consider 2 inputs, right? Separate 2 inputs. That's why, and it's multiplied by 2 0, W8 to 0 0. Here we construct the butterflies considering 4 inputs. That's why first butterfly multiplied by W4 is to 0. Okay. Second butterfly, this one multiplied by W4 is to 1. Just remember this. Okay. Then x of 0, how we can calculate it? X of 0 means, what is the first output of this one? This butterfly? It's 1. 1 plus W4 is to 0. Okay. What is the third input here? The second butterfly first output, that is 3. Then we will get x of 0. How we can consider the x of 1 next here? X of 1. X of 1 from the butterfly, second butterfly structure. See here, what is the value here? It's 2 plus W4 is to 1. Okay. Which value we consider here? W4 is to 1. Fourth value we consider. Okay. 4. Then x up to. See here, x up to we considered by using this one, right? 1. Okay. Minus sign here. Minus sign. W4 is to 0. That is 1 means W4 is to 0. Third input. This third value. Then x of 3. The second way here. Second here. This one. X up to, sorry, x dash up to, we can consider this one. 2 minus sign. 2 minus sign. W4 is to 1. Okay. Which value here? We consider fourth value. Like that we can do the simplification. Okay. Inputs, this one is the time decimation in time. This problem is on decimation in time. In decimation in time, okay, inputs are in bit reverse order and outputs are in sequence. Outputs are in sequence. You already know, you are familiar with how to write in bit reverse order. Okay. Please go through this 4-point DFT. Otherwise, see here. Now, the naturally occurring input samples indices 0, 1, 2, 3 are represented by their binary equivalents 0, 0, 0, 1, 1, 0, and 1, 1. These values are indicated by 0, 0, 0, 1, 1, 0, 1, 1, like that. Okay. Then here, we can write it in bit reverse order. That means right to left, 0, 0, 1, 0, 0 and 1, and 1 and 1. Like that also we can do it. Then this is 1, this is 2, okay, this is 1, sorry, this is 0, this is 2, this is 1, and this is 3. Okay, this process of rearrangement of indices for DFT computation is called bit reversing. Okay, this is called as bit reversing. Okay. In decimation in time, the inputs are in bit reverse order. Output is in sequence. Okay. If you consider two inputs to construct the butterfly, okay, here you consider two inputs, right? That's why this line is multiplied by W2 raised to 0. If you consider the four inputs to construct the butterfly, then, okay, this first butterfly is multiplied by W4 is to 0. Okay, second butterfly is multiplied by W4 is to 1. Okay, and second output of the butterfly always is minus 1. First input minus second input. Okay, just remember this. Now we consider 8-point DFT computation. 8-point DFT computation. Yeah, okay. When 8 points are used to compute DFT, the result is the computation structure of figure 1C. See here, n value is equal to 8. Okay, 8 is 2 to the power of 3. 2 to the power of 3 means how many stages? 3 stages. Okay, just remember in each stage, okay, in first stage, 3 butterflies, and second stage, sorry, in first stage 4, in second stage 4, and in third stage also 4 butterflies. Okay, just remember here, we can write the inputs are in bit reverse order. First x of 0 will come, next x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, and x of 7. Now, by considering two inputs, consider the butterfly. This one, and this one. Here, the second output with subtraction, -1, -1, -1. If you want to here write W2 raised to 0, W2 raised to 0, W2 raised to 0, W2 raised to 0. Then here, in second stage, consider only 4. In first stage 2, second stage is 4, in third stage is 8 inputs. Okay, in fourth stage, 16 inputs you can consider. Okay, see, I'll tell you. First, you can consider 4 inputs. Okay, here 1 and 3, and 2 and 4. 1 and 3. 1 and 3. This constructs the first butterfly. This second and 4 which consider the second. And here 4 inputs you consider, right? Here, right, multiplied by W4 is to 0, this one, and this one he written here W8 raised to 2. W8 raised to 2 is equal to W4 is to 1. W4 is to 1. Because here n is 8 value, that's why replace W4 is to 1 by W8 raised to 2, that's why. Okay, then again another consider 4 inputs, then draw the butterflies, construct the butterfly. This is second stage. Then here this one. Now, if we consider the 8 inputs, consider the 8 inputs, 8 outputs of the previous. Okay, for that you can construct the butterflies. First here, divide it, half. Here 4, here 4. X of 0 will get using this here, x of 4 line, using this. Then this line and this line. Here you can write W8 raised to 0, W8 raised to 1, 8 raised to 2, 8 raised to 3. Okay, this is stage 3. See how many number of the butterflies here? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. How many butterflies? 4 into 3. How many butterflies for 8-point DFT? How many butterflies for 8-point DFT?
12.
12, right? See here. 12. Okay. How many stages? Just remember, in each stage 4. In each stage 4. If it is 16 means how many butterflies in each stage? Half. Just tell me, if n equal to 16, they ask the question so many times. If n equal to 16, okay, what is the number of stages? What is the stages? How many stages? If it is n equal to 16 means 2
8.
is to 4, right? 2 is to 4, right? 16 is equal to 2 into 2, 4 into 2, 8 into 2, 16. That means, what is the power here? What is the power here? 4, right? Then that power is the number of stages. One stage, second, third, and fourth. Then in each stage, how many butterflies? In each stage, how many butterflies? N equal to 16, right? N equal to 16. Okay. In each stage, n divided by 2 number of butterflies. Just remember this. In each stage, n divided by 2 of the butterflies. What is the n value here? 16. Right? 16 divided by 2, 8. Okay. Then, what is the total number of the butterflies? What is the total number of the butterflies? How many number of the butterflies? Here, in each stage, 8. How many stages? 4 stages. 4 into 8. How much? 8 4 is 32.
32.
Just remember here. In each stage, n divided by 2 number of the stages. If n equal to 16 means 8 number of the stages in each, 8 number of the butterflies in each stage. Okay. For n equal to 16, there are 4 stages. Okay. Then for each stage, 8 butterflies. That's why 4 multiplied with 8, then 32 number of the butterflies required for n equal to 16. Just remember this, it's very important. So many times they ask the question. Okay, better you go for the solution what I sent in the WhatsApp group. Okay, it's very important. Just remember how we can construct the butterfly. In first stage, separate 2 inputs. In second stage, 4 inputs you consider, first and 3, and second and 4. Using that, you construct the butterfly. Okay, if again in third stage 8 inputs means first input, okay, first line and fifth line, second line, sixth line, like that. Okay, and here the second input of the butterflies, okay, always multiplied by total factor W8 raised to 0, W8 raised to 1, 8 raised to 2, 8 raised to 3. Here we construct the butterflies considering 8 means here write W8 raised to 1, 8 raised to 2, 8 raised to 3. If you construct the butterflies using 4 inputs, then W4 is to 0, W4 is to 1 here. Okay, just remember this. Now, a butterfly computation, okay, below here, a general, wait a minute, a general DIT FFT butterfly DIT FFT. What is meant by DIT FFT? Decimation in time. Okay. Past Fourier transform butterfly in place computation structure is shown in figure. Its implementation requires the following computation. If it is the inputs are complex values. Okay, here which consists of real value and imaginary value. First input and second input. Okay, and it's multiplied by total factor, right? See here. Second line, okay, of the butterfly is multiplied by total factor, right? W4 is to 0, W8 is to 1, W8 is to 2, 8 is to 3, right? Like that. If I consider total factor is, okay, total factor is a complex value, okay, real value and imaginary value. WR is to R plus J of WI of R. Okay, and minus 1 here. And outputs are AI dash plus J of AI dash, BI dash plus J of BI. Okay, now consider this one. AI dash plus J AI dash equal to first input AR plus JI plus, okay, multiply this second input by this total factor BR plus JBI WRR plus JWIR. Okay, just remember here J value. J equal, what is the value of J? Anyone? What is the value of J? Hello?
Square root of minus
Square root of minus 1. What is the value of J square?
plus 1.
Minus 1, right?
Minus 1.
Minus 1, right? Just remember this while solving this equations. Okay? Here, multiply with AR. Okay, you can simplify this one. Okay, first you here you can solve this one. Already solved here. BRWRR plus, okay, J of the BRWIR plus JBIWRR. Okay, then J into J minus 1, right? Minus of BIWIR. Okay, for this term you can multiply. This term is multiplied by this AR plus JAI. This term next again multiplied by AR plus JAI. Then here we'll get AR plus BRWRR minus BIWIR plus J times of AI plus BIWRR plus BRWIR. Just remember this one is equation number 1. Similarly, BR dash plus JBI dash. Okay, what is the first input here? AR plus JAI. Okay, right, JAI minus sign. This input is multiplied by this one. Okay, J time, okay, BR plus JBI multiplied with WRR plus JWIR. Total factor. Okay, then here again simplify this equation and separate the real terms and imaginary terms. Imaginary term means which consists of J. Okay, after simplifying we get equation number. Okay, now equating real and imaginary parts. See here AR dash plus JAI. Here separately we have the real and imaginary, right? Then equate the real value and imaginary value. I will take this AR dash is equal to this one. Okay, then this AI dash is equal to this imaginary term. Okay, similarly BR dash is equal to this real term and this BI dash is equal to this term. Okay, equating real and imaginary parts. Okay, then here we'll get this is AR dash, AI dash, BR dash, and BI. Here I will write this term. Which term here I will consider here. AR as it is. TEMP1, temp1. What is temp1 here? BRWRR, BIWIR. See here, AR dash and BR dash would consist of same parameters here. This consider here. Sorry, not this one. Wait a minute. Yeah, this is temp1, TEMP1. Okay. Then again, AI dash, AI plus TEMP2. TEMP2. Okay. Then BIWRR plus BR WIR. Next here, BR dash, which consists of BR WRR plus BI WIR. Here also same term, here also same term. Okay, here when this TEMP1, this one, TEMP1, I'll consider, I will write here, then you will get it here. TE, I'll leave it, I'll show it. BR dash you can consider. When multiply this term by minus sign, what will happen? Minus it becomes, okay, minus minus plus it becomes, that's why BR dash is equal to ER minus TEMP1 within the bracket here, within the bracket. Okay, here also within the bracket. What is temp 1 here? BR WRR minus BI WIR. Okay, what is temp 2? Just reverse of this one. BI WRR, in the place of BR, BI will come. In the place of BI, BR will come. Okay, the total factor is real value, here imaginary value, and sign will be changes. Sign will be changes. Okay, just see the difference. Okay, how we can, AR dash means equal to AR plus temp 1 with respect to second inputs. Real value of the second input, imaginary value of the second inputs, we can, and also consist of total factor. Okay, temp 1 we consist of BR with real value of the total, BI with imaginary value of the total factor. Sign is minus. Temp 2, it's just reverse here. WR and WI keep as it is. Keep WR and WI as it is. Replace BR by BI and BI by BR here. Okay, see here. BR by BI, BI by BR. Here minus sign, here plus sign. Okay, thus to compute the butterflies, one can use equation number 4 and 5. So first compute the EMP1 and EMP2. Okay, it's very important. Please go through this. Okay, if you consider the complex values, inputs are complex values, total factor is also complex values. What do you mean by complex values? Anybody? What is complex values? What is complex values? Hello? Complex values in the Hello? Is it audible? Complex values means if it consists of real value and imaginary value. Okay? Hello? Yes, leave it. Here, n equal to 2 raised to m point FFT computation. The above approach to DFT computation extended to a case of n points, where n is a power of 2, which is log of n with base 2 stages of computation, with each stage requiring n divided by 2 butterflies. This computational structure is the fast Fourier transform or FFT. The two types of the commonly used FFT algorithms are available. One is decimation in time and another one is decimation in frequency. Here I explained in decimation in time what will happen, in decimation in frequency what will happen. It is a naturally occurring input time samples, indices are bit reverse. Inputs are bit reverse, okay, in the decimation in time, and processed by the above algorithm. The frequency domain output is in the natural order. Such a computation is called a DIT FFT algorithm. Okay, in decimation time, time domain sequences are or input sequences are bit reverse order and outputs are in sequence or in natural order 0, 1, 2, 3, 4, 5, 6 and so on. If a time domain sample sequence is used without bit reversing the indices, okay, with small changes in the butterfly computation structure, this second approach is called a DIF-FFT algorithm. Here, in DIF-FFT, what will happen? Inputs are in natural order. Outputs, that means a capital X of 0, X of 1, that is in sequence, bit reverse order. Then we have some small changes in the butterfly. See here, exact reverse of the this one. Here the inputs I will write here, then you will get it. Butterfly structure DIFF. These are the inputs. Inputs are not this one. Small x you can write. Small x. Small x. Small x. Small x. Okay. This is remaining same. This is the first stage. Okay. This is second stage, and this one is third stage. Okay. This is capital X. Capital X. Just you can fold this one. Just you can fold this one. Then here, first in this decimation in frequency, inputs is in sequence. Inputs are in sequence, time domain sequence. And first to consider the butterfly, we consider the first 8 inputs. Second, next 4 inputs and 2 inputs. And just remember here, in this butterfly, in decimation in frequency, I'll show you how the -1 input A input B. Okay, here if it is A dash means this is A dash, B dash. See here, what is A dash? Same as it is A plus B. A just write it. Okay, A dash is equal to A plus B. What is B dash here? A minus B. Okay, this is the second input is multiplied by total factor. See here, second input is just reverse. Second input is, sorry, the whole input A minus B is multiplied by, see here, I'll write here B dash. B dash is equal to first input okay multiplied by total factor. Just remember, it's very important. Okay, please go through this. Okay, best example this one only. These are the inputs: x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. Okay, just you can hold it. This x of 0 will come left hand side. These will come right hand side. Okay, these are the inputs, here these are the outputs. Okay, just remember, they ask the briefly explain the structures of DIT, FFT and DIF, FFT when n is equal to 8. Draw the butterfly structures. Okay, but you can draw the 8-point DFT, just reverse it. Okay, that is 8-point DIF, FFT. Okay, if you have any doubts, do you have any doubts? Please maintain the attendance. It's very low. It's 19 students are joined, means very less as the attendance out of 31. Okay, 18 students. Okay, do you have any doubts? Yes or no?
No, sir.
Okay, thank you.